Hello everyone, welcome to Neelam tutorial. And in today's video, here we are to tell about some important reactions from carboxylic acid. So the very first we have over here is Hell-Vollard-Zelinsky reaction. Next we have decarboxylation reaction and Claisen condensation reaction. So you will find those questions as a must repeated one in carboxylic acid. Let's move on with each of them. So the very first reaction, that is Hell-Vollard-Zelinsky reaction, what is it saying? So it's simply saying that when carboxylic acid reacts with, so we need a carboxylic acid. So let me take a carboxylic acid, R, C double bond O, OH. So when carboxylic acid reacts with chlorine or bromine, so either it can react with the chlorine or bromine in the presence of red phosphorus. So it need to react with chlorine or bromine in the presence of red phosphorus. So any of them can be used. Let me write. Let me remove this R as well. Okay. Instead of that R, I'm just putting CH3 group. Okay. So what am I doing is I'm treating it with the chlorine in the presence of red phosphorus. So what exactly is alpha carbon? So carbon just beside carbonyl carbon is known as alpha carbon, and the alpha carbon has 3 hydrogen in this case. So what it is saying is they give alpha halogenated carboxylic acid. This reaction continues till हाइड्रोजन एटम ऑफ द अल्फा पोजीशन आर रिप्लेस्ड बाय हेलोजन एटम. ये क्या बोल रहा है कि ये रिएक्शन तब तक होता है जब तक अल्फा पोजीशन के कार्बन के सारे हाइड्रोजन को रिप्लेस ना कर दे कौन, हेलोजन. ठीक है, बोलने की मतलब अगर मैं यहाँ से एक हाइड्रोजन कम करूँ इस वाले कार्बन से और उसके बदले क्या लाए हम, ये क्लोरीन बॉन्ड ब्रेक करेगा ऐसे, and this will come and attach right to this carbon, and the compound, those form will look something like this: CH2 Cl, and here it will be C double bond O, OH. Further I'm treating it with chlorine in the presence of red phosphorus. Further what will happen is still in the alpha position, alpha carbon, this one is your alpha carbon, still there are 2 hydrogen. So what will happen, the chlorine will come and replace the next carbon, next hydrogen. So it will be CCl2, and C will have only one H now, and it will be like C double bond O, OH group. Okay. Further if I will treat it with chlorine and red phosphorus, chlorine in the presence of red phosphorus, it will further replace one hydrogen is still there in the alpha carbon. What will happen is even this hydrogen will be replaced by chlorine. So what will be the product is, it will be C and Cl3, and there will be the formation of C double bond O, OH. So simple what it is saying is the reaction continues. reaction कब तक होता है, जब तक अल्फा हाइड्रोजन में till हाइड्रोजन एटम इन द अल्फा पोजीशन आर रिप्लेस्ड बाय हेलोजन एटम. तो ये रिएक्शन तब तक होता है जब तक अल्फा पोजीशन के सारे हाइड्रोजन को कौन रिप्लेस ना कर दे, हेलोजन. एक और एग्जांपल देके एक्सप्लेन कर देते हैं. लेट मी टेक अनदर एग्जांपल. सॉरी दैट आई एम टेकिंग CH3 CH2 C double bond O, OH, and I am treating it with chlorine in the presence of red phosphorus. Okay, so in this case my alpha carbon is not this one, here the alpha carbon is this one, and it is having how many hydrogen, 2. Now the chlorine will replace, or chlorine will come and attack this position. Chlorine will replace this hydrogen, and it will replace the position of the hydrogen in the alpha carbon. Okay, so what product I'll get over here? So the product those obtained will be CH3, CH2 was there, so CH, and there you will have a Cl group. Next you will have C double bond O, OH. Okay, next what will happen, further the reaction will continue because still you can see that there is one alpha carbon, alpha hydrogen. Further, I am treating it with red phosphorus and chlorine. Now the product will be CH3C, and it is having 2 Cl group along with the leverage formation of C double bond O OH. So this reaction is known as Hell-Vollard-Zielinski reaction. सिंपल क्या बोल रहा है, तो जब आप कार्बोक्सिलिक एसिड, कैसा कार्बोक्सिलिक एसिड, तो जिसमें अल्फा हाइड्रोजन हो, उसको अगर आप रेड फॉस्फोरस के साथ क्लोरीन या ब्रोमीन पास करवाते हो, तो उस कार्बोक्सिलिक एसिड की अल्फा पोजीशन में जो भी कार्बन में जो भी हाइड्रोजन है उसको रिप्लेस कौन करेगा, हेलोजन. ठीक है, सारे हाइड्रोजन हट जाएगा और उसके बदले कौन आ जाएगा, हेलोजन आ जाएगा. सो लेट्स मूव ऑन फॉर द नेक्स्ट वन, दैट इज योर Claisen condensation reaction. So what it is saying, an ester containing, so what are we in need of, we are in need of ester. An ester containing, what should it contain, at least one alpha hydrogen. So you need a ester having at least one alpha hydrogen. एक ऐसा ester चाहिए जिसमें अल्फा हाइड्रोजन हो, और उसको किसके साथ ट्रीट करवाना है, तो उसको ट्रीट करवाना है हमें ट्रीटेड विथ स्ट्रॉन्ग बेस लाइक सोडियम मेथॉक्साइड. हमें एक स्ट्रॉन्ग बेस के साथ उसको ट्रीट करवाना है जैसे सोडियम मेथॉक्साइड. तो वो क्या देगा, तो आपको बोल रहा है कि वो हमें देगा बीटा केटो एस्टर. ठीक है, लेट मी टेक दिस, ओके sorry, let me take a ester. So ester is basically, let me take it like CH3 C double bond O O CH3. Okay, so over here this one is my ester. Let me take another ester which also looks like CH3 C double bond O O CH3. And I need to treat it in the presence of sodium ethoxide. So ethoxide is C2H5ONa, sodium ethoxide. What will happen, what it is saying is, यहाँ पे होगा क्या कि ये कार्बन आपकी कौन सी कार्बन है, अल्फा कार्बन है. इस कार्बन में हमारे पास कितने हाइड्रोजन हैं, तो 3 हाइड्रोजन है. तो अगर मैं इसको ऐसे लिखूँ, अगर हम इसको ऐसे लिख दें कि ये हाइड्रोजन एंड here also I am giving one hydrogen. So what will happen is, one of the hydrogen right from here will break the bond, and this will break the bond right here. The H plus over here, this H plus will come and attack right with this to form alcohol, and the carbon will come and join with this carbonyl group in order to form a product which looks like CH3 C double bond O. And then this group is CH2 C double bond O O CH3. So here what you can see is, this is the steel and ester, and this one is ketonic group. So in the beta, this is alpha carbon, this one is beta carbon. So in the beta position we have keto, so we call it beta keto ester. Okay, so when carboxylic acid having alpha hydrogen, so this reaction is only possible when you have, ester, when you have an ester having alpha hydrogen, okay, is treated with sodium methoxide or a strong base, it forms beta keto ester, and this reaction is known as Claisen condensation reaction. Okay, let me take one more example of this, or I'll give you a question, you people kindly try it out. आप लोग खुद से ट्राई करना, एक देते हैं आपको. CH3 CH2 C डबल बॉन्ड O CH3. ठीक है, ये आपके पास एक एस्टर है, और इस ये वाली कार्बन इसके लिए अल्फ़ा कार्बन है, इसके पास यहाँ पे हाइड्रोजन है. तो फिर आपको ये चीज़ सोचना है. वापस से मेरे पास मान लो सेम एस्टर ग्रुप है. ठीक है, वापस से हम सेम बनाते हैं यहाँ पे CH3, और इसको लिखते हैं CH2 को ऐसे लिख देते हैं H और H, और ये हो गया आपका C डबल बॉन्ड O CH3. इसको ट्रीट करना है किसके प्रेजेंस में, तो सोडियम मेथॉक्साइड C2H5ONa. ठीक है, तो ये बनेगा क्या, आपको ऑलरेडी मैंने बोला है कि अल्फ़ा कार्बन के हाइड्रोजन क्या करेगा, ये प्लस चार्ज बन के निकलेगा, और ये बॉन्ड यहाँ से ब्रेक होगा कार्बोनाइल और ऑक्सीजन के बीच से, This hydrogen will go and attach with this oxygen in order to form alcohol. And the carbon having the negative charge will come and attack the carbonyl group. This carbon will come and link with this carbon. Okay. So the product those formed will be like CH3, CH2, C double bond O, and here it is CH. Okay. And then you are having C double bond O, O, CH3. And in this carbon, there you have the CH3 as well. So I am writing it right here, CH3. So this is my alpha carbon and this is my beta carbon. And here it is your beta ketoester along with the liberation of CH3OH. So this is the known as Claisen condensation reaction. Let's move further for Hofmann bromide reaction. So what exactly is Hofmann bromide reaction? What type of reaction is known as Hofmann bromide reaction? Okay. This is most important or repeatedly asked one. Basically, in this reaction, what will happen is one carbon atom will be less. So if you have like ethanamide, you will get methane, something as such. Okay, so one carbon will be like comparatively less than that of the parent. So it is saying when an amide, so what are you in need of? Amide. Amide is RCONH2. Is heated with, you need to heat it with bromine and a strong alkali. So you need to take an amide and heat it with bromine and a strong alkali in the presence of a primary amine. Especially you need a primary amine having one carbon atom less than, you will get a primary amine. So before you took amide and now you will get amine which will have one carbon atom less than the parent amide is formed, and this reaction is known as your decarbonylation reaction or Hofmann bromide reaction. Okay, let me explain you this one with a example. So I'm taking CH3, sorry, here you have CH3, C double bond O, NH2. So this is your eth N amide. When an ethanamide is treated with, what do you need to treat it with? So you need to treat it with bromine. Okay. And in the presence of a strong alkali. So what do you need? You need a strong alkali like KOH. And you need to hit it. Okay. What will form? So it is saying that this carbonyl group sorry will be removed and this NH2 will come and attack directly with this carbon. So it will be CH3NH2 along with the formation of KBr and then water along with the liberation of K2CO3. So the byproduct will almost remain same. Okay, every time your byproduct will be the same one, that is KBr, H2O and K2CO3 along with the liberation of alkanamide. So alkane will be able, like as such, what type of amide you will use, it will depend on that. Okay, and you need to treat it with bromine and strong alkali. Okay, and you need to heat it out. So this reaction is known as Hofmann bromide reaction, or we also call it decarbonylation reaction. Let me take another example. C6H5CONH2. So what is this? C6H5 is benzene ring. CONH2 being treated with the bromine and KOH, and you need to heat it. Okay, what will form? Again this carbonyl carbon will be removed and this NH2 will directly attack right there. So it will form C6H5NH2. So directly it is aniline along with the liberation of same group, that is KBr, water and K2CO3. Okay, so here it is aniline and here you have benzamide. So this reaction is known as decarbonylation reaction. Thank you so much for watching the video. If you have any queries, do ask in the comment section. We'll be surely replying it. And we'll try to add some questions related to this video in the comment section or in the description box. If you will be able to solve them, click and put it in the comment section. Thank you so much.